Bismillahirrahmanirrahim. Assalamu alaikum. How are you all? I hope that all of you are doing well and staying safe. In the first part of today's lecture, we studied the hierarchy of internet, the tier 1, tier 2, and tier 3 ISPs, and we talked about the internet exchange points or IXPs, and then we learned that how the data is actually being exchanged from one ISP to the other ISP, and how the end systems, the computers actually communicate with each other through that hierarchy of the internet. Today we are going to talk about the same infrastructure that is holding the internet. ISP was the first thing in that, and the second thing actually is a router. A router is a device which directs the data packets from the source to the destination. Consider a packet like a really, really dumb person. That person doesn't have anything but the address where he came from and the address he wants to go to, but he cannot locate the path himself. So he keeps asking the people he see along the way to guide him towards his destination. They would just check the address and then guide that person towards the appropriate route that that is going to take him to the destination. That's exactly what the router do for the packets. You are actually familiar with this thing. Most of you have the DSL internet connection at their home, and your DSL modem is also working as a router. Excuse me. So, a router is usually connected to two or more data lines. In the example of your home, it is connected to your home on one side, and on the other side, it is connected to the ISP. When the data packet comes from one line, the router actually looks at the address of the data packet and then redirects it to its destination. In our example of our home, the data packets that are originating from our home computers are being directed to the ISP by the router, and then the ISP has its own routers which are directing the packets to its destination. The interconnected network or the internet is actually made up of countless routers. A router can be used within a small LAN or locally, or it can also be used at the ISP side. The servers are also connected with the help of the router. So the router actually is taking packet from one network and then sending it to another network, and then the router of that network is redirecting the packets toward the further networks. Router actually contains an information called routing tables. It actually knows that which IP belongs to which area. Remember we talked about IP addresses a little. The detailed lecture about IP addresses were V4 and V6 will be in the next week inshallah. But for now, I would like to remind you that an IP address actually shows the location of a computer on a network. Just like your landline telephone numbers actually shows the location of a landline, IP addresses similarly work. by showing the location of a computer on a network. So router actually have that information routing table that which IP address belong to which area. And then when the packet comes, router keeps redirecting the packet towards the network of that area, one router after the other, until it reaches its destination node. There are several advantages of routers. Remember, we studied the CSMACD, the Carrier Sense Multiple Access and Collision Detection Protocol, which was placed in case there was a collision of transmission. But router actually limits the chances of collision. Collision doesn't occur in the router because it actually is able to broadcast, multicast, and unicast the data towards a specific destination. Then routers can be used in all kinds of networks, like your local area network, your metropolitan area network, your wide area network. All sorts of networks can be connected with the router. A router can be used with a twisted pair cable. It can be used wirelessly. It can be used with other form of transmission media. And also a router can work with the different architectures. Different topologies can also be handled with the help of a router. Different architectures, different technologies to make a network can be dealt with a single router. As I explained in the previous slide, the router actually guides the packet towards its destination. The router can actually determine the best possible path depending on the bandwidth at that time, which packet to be redirected to which path. Remember, in the packet switching, each packet can take an individual path, a different paths to reach from the same source to the same destination. The paths can be different. The routers can select the best possible path for an incoming packet uh, as to where to redirect the packet to. And also, routers can be used to filter the broadcast. You can uh, place the policies what kind of traffic should pass through the router and what kind of traffic should be blocked. After that, it has some disadvantages or limitations as well. First of which, it's a bit expensive than the rest of the networking devices like hubs and bridges and switches. Router is actually, you can say, a small computer, so it's a bit more expensive than the rest of the networking devices. Then router can only work with the routable protocols like the TCP/IP or UDP. Router has its own software installed in that as well. So those softwares are usually updated by the manufacturer companies as well. Updates can be installed manually or automatically, and that actually downloading, installing the updates would consume the bandwidth as well. Then, as we discussed about the filtering of the packet, uh, policy has been placed to scrutinize the packets, check the packets whether they are allowed to pass through the network or not. So that packet filtering, if it is increased, if there is a lot of packet filtering to do, the transmission would be a little bit delayed. So that will cause latency. Would cause the delay in the transmission. The next thing we need to talk about is public switch telephone networks or PSTNs. Previously, they were known as POTS, plain old telephone lines. Now, as the internet was starting to emerge, the computers needed to be connected with each other. And at that point, we didn't have any particular infrastructure to make a network of such magnitude. Imagine laying a cable throughout whole of the city or between the cities or between the countries to connect computers. So what we did, we actually adopted to use the existing telephone network to connect our computers together. This is actually the public switched telephone network. It has a few components. A switching office, which I think you know by the name of telephone exchange. The transmission facilities means the transmission mediums, the lines, the actually the telephone cables that are running from your home landline to the exchange machine and then to the main exchange office. And the customer premise equipment means the part of the equipment which is placed at your home, maybe the landline telephone set. That's actually one of the equipment that can be used as an example.